the first thing we're going to do is check out the map function. You can see here, right when I type map, I'm getting some syntax highlighting, so it's green, and that indicates to me this is a built-in function. And as we know, we can use Shift-Tab to check out the documentation string. And you can see here, it expects a func, and that's short code for function, and then some sort of iterable object. You can expand this, and it'll explain a little more about what it does. But the best way to actually realize what it does is to just show you. Since we know it's expecting a function, let's quickly create a function. We'll use our def keyword, and we're going to create a simple function that just takes in a number and returns its square. So we will define a function called square, takes in a number, and it returns that number to the power of 2, or the square of that number. Now let's imagine I have a list of numbers. And my numbers are 1, 2, 3, 4, 5. And what I want to do is I want to apply the square function to every single number in my nums list. Well, one way I could do that is use a for loop, but that may take a while and it's a lot of code. Instead, what I want to do is take advantage of that map function. So the map function, what you end up doing is you pass in the function that you want to map to every single element or item in this list. So then we can say my nums. Now notice what happens when I just run it like this. I get back this kind of cryptic statement which says, hey, you have a map at this location on your computer. So this is a memory location. This by itself isn't super useful. What we need to do is actually iterate through this. So what I can do now is say for item in map print item. And what this does is it generates applying this square function to every single item in this list. So 1 to the power of 2 is 1, and 2 to the power of 2 is 4, then 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So that's one way to quickly iterate through this. Another way you may want to use this is if you actually want the list back, you can call the built-in list function on your map, and then pass in square and my nums here. And now when you run this, you get back the actual list, 1, 4, 9, 16, 25. And these functions can actually be a lot more complex than just this simple square function. So let's show you a function that works with strings. We'll call this function splicer. And it takes in a string. I'll say it takes in my string. And what it's going to do is it's going to say if the length of my string mod 2 is equal to 0, well that means it has an even number of characters in that string because the remainder after dividing by 2 is equal to 0. And in that case, we're going to return the word even, or the string even. Else, we're actually just going to return the first character of that string. We'll say my string 0. So this is a little more complex of a function than we saw up here, but it's going to work just the same way when we map it. So let's create a list of names. We'll say Andy, Eve, and let's say Sally. And then we're going to, after we call list, map our splicer function to our names. We run this, and now we get back even for names that have an even number of letters in them, and we only get back first letters for names that have an odd number of letters to them. And now you can see the flexibility. You can pretty much do any function you want as long as it's going to successfully take in the argument or parameter that you pass in with this list or with any iterable object. So that's how you can use the map function. Something that I want to make really clear here when you're using the map function, notice how I'm passing in square and how I'm passing in splicer. I'm actually not calling them to execute inside of this map because map by itself is later on going to execute them. Pass in the function here to map, you do not add in the open and close parentheses. Instead, you just pass in the function itself as an argument. And that's a really important detail to note here. Otherwise, if you do this, you'll end up getting some sort of type error. It's going to say, hey, you're missing one required positional argument. Or it's going to say something like, hey, we're not able to apply splicer calls to names. And that's because we just want to pass in the function itself. We don't want to execute the function. We'll let map do that for us. That's the map function. And now let's learn about the filter function. The filter function returns an iterator yielding those items of the iterable for which when you pass in the item into the function, it's true. And that just means that you need to filter by a function that returns either true or false. Let's create a function that returns either true or false. We'll create a function called checkEven, and it takes in a number. And all this function does is it returns back whether or not this is an even number. So we will say, as we've seen many times before, return num mod 2 equal to 0. Because when you divide this number by 2, the remainder, if it's 0, then that means that it's even. If not, then we return false, and it's an odd number. Then I'm going to create a list of my numbers, and we'll have it be 1, 2, 3, 4, 5, 6. Now let's imagine I only want to grab even numbers from this list, or I only want to grab numbers that pass some sort of condition based off a function that I previously defined. What I could do is use the filter function. And it's very similar to what we just saw with map. But what map did is map applied this function to every element in that list. Filter, instead, what it's going to do is it's going to filter based off this function's condition. So this function, when you're using a filter, has to return a Boolean, has to return either true or false. And then what we're going to do here is say apply checkEven to my nums. And again, just like last time, if you run this by itself, it's going to say, hey, you have a filter object at this point in your memory. Instead, what we want to do is either transform it to a list so that we get back only the even numbers here, or we can iterate through it. So we can say for n in filter apply checkEven to my nums, print out n, and we see here we've printed out 2, 4, 6. So you can either transform it to a list or iterate through the results on that, the results that this filter function is generating. Now that we've learned about the map function and the filter function, we can learn about Lambda expressions and see in context why they're really useful. So what we're going to do is show you my favorite way of explaining the Lambda expression, and that's by converting a function step by step into a Lambda expression. And then we'll actually explain more formally what a Lambda expression is. So I'm going to take that square function we did earlier, or at least a really similar function to it, and define it here. So notice what I have. I have def square num, and I say the result is equal to num to the power of 2 return result. Now if I call square, let's make sure I spell that right. If I call square on a number, I get back the square. What I'm going to do now is slowly, step by step, turn this into a Lambda expression. So first off, let's see how we can simplify this. Right now, I'm assigning result equal to num to the power of 2 and then returning that result. What I could do instead is just get rid of this assignment and return num to the power of 2. And if I run this, it's the exact same thing. And what I could also do is actually write this all on one line. And typically, you wouldn't do this because it's bad styling and not by convention, but Python won't actually complain here, and it will let you run this all on one line. Now, we're almost in the form of a Lambda expression. In fact, we can easily convert this into a Lambda expression through the following manner. A Lambda expression is also known as an anonymous function, and the reason for that is because it's some functionality that you intend to only use one time. Because of that, we don't actually give it a name, nor do we use the def keyword. So instead of a name or the def keyword, we replace that with the keyword lambda. So I'm going to get rid of this and just say lambda here. And then we say lambda num colon, and the return keyword is basically, we get rid of that because it's assumed that we're going to return whatever's on the other side of this colon. And there we have it. This is now a Lambda expression. And I could, if I wanted to, assign it to square, run that, and then I see square still working. So let me make this to another number. We see 5 to the power of 2 is 25. Now I just mentioned that lambdas are anonymous functions and you typically don't name them. So a lot of times you're not really going to be doing this square is equal to some lambda expression. Instead, you're going to be using it in conjunction with other functions, such as map and filter. So we look up here, and we see that earlier when I was using map, I was passing in this square function and applying it to every item in this list, my nums. Now that required me to actually define square fully here. But what if I only intend to use this one time? Do I want to take up space by defining this function here and then having to call it here? What I could do instead is just call a lambda expression. And this is where lambda expressions really begin to shine, and this is why you would use them. I could just say map lambda num colon num to the power of 2, and then apply that to a list of numbers, such as my nums, and then cast that to a list, and we get back the same thing here. Every number in the my nums list has now been squared. Now that we've seen how we can use lambda with the map function, let's quickly check how we can use it with the filter function. So up here we saw that we were filtering using this check even function. So let's start by converting this check even into a lambda expression. We'll come over here, we'll remove the name and the DEF and replace that all with the lambda keyword. Remove that parentheses and then get rid of return here and put it all in one line. And now we have our lambda expression. Then we're going to pass this into filter along with the list of numbers we want to filter. And to get the results, we'll pass this into list. And then we run that back, we'll get back 2, 4, 6, only the even numbers. And lambda expressions can be used for a variety of things. Let's imagine that you wanted to grab the first character of a string. So let's create a list here. Well, we actually have the names list. So we have Andy, Eve, Sally, and we only want to grab, let's say, these first letters. What I could do is map lambda, and I can take the incoming name, and I want to return back only the first character at index 0 of names. And you can call this whatever you want. It doesn't have to be name. It could be X here or any other variable, just like for any normal function. And let's pass this to a list so we can see the results. And there we go, AES. Now let's imagine I wanted to reverse the actual names. What I could do is say colon colon -1, and then that will reverse the names, just as we've seen with slicing before. You can even pass in multiple arguments into a lambda expression. However, keep in mind that not every function that we've seen up here, for example, this check even or splicer or square, not every single complex function is going to be directly translated to a lambda expression. So you should really only use lambda expressions when you can still easily read it if you were to come back to your code later. And as you get more and more experience with Python, you'll be able to quickly realize what a lambda expression is doing. But in the beginning, it's going to be a bit tricky at first. So if you ever struggle of trying to convert a normal function to a lambda expression, just try using a normal function instead. All right, that's the basics of map, filter, and lambda expressions. We'll see you at the next lecture.